Previously, we have discussed the confidence interval problems for population mean. Now, in this presentation, we would focus on the same type of problems for population proportion, which is P. This is the central limit theorem results on sampling distribution of the sample proportions. The formula for confidence interval follows the same structure as that for population mean. It's also the point estimate plus minus the z multiplier times the standard error. The point estimate is the sample proportion P bar, and the standard error, as we've seen from previous slide, is square root of P times 1 minus P divided by sample size. It is also worth noting that we use z multiplier here for population proportion confidence interval estimations. Because we do not have the population proportion P, but only the sample proportion P bar, we would have to approximate P in the formula by P bar. In this example, we would want to calculate the sample proportion of finance majors first. That would be 10 over 36, because 10 students out of 36 intend to concentrate in finance. The sample proportion P bar is 0.2778. The rest of the calculations involves finding a z multiplier, which is 2.575 for a 99% confidence level. Some of you may remember this from previous video, and plugging the sample proportion into the formula. In summary, a 99% confidence interval estimate for the percentage of finance majors is between 8.56% to 47%. The calculations are identical when the confidence level is changed to 95% or 90%. The only difference lies in the z multipliers. As the confidence level falls, the confidence interval estimate also shrinks. For our example, a total of 36 students were sampled. The resulting margin of error at 99% confidence level is 0.192, that's about 19%. If we were to reduce the MOE to only 5%, how many students do we need to sample this time? You may probably realize that this is a sample size problem again, asking us to find a minimum number of students we need to recruit for our survey. All the sample size formula for different types of problems are summarized here. For categorical data, occasionally sample proportion P bar is not given. To find a minimum sample size for certain MOE, we may use a conservative choice of a P bar. That is to set P bar to be half, 50%. This is used in the following example. In this example, we would like to have a confidence interval of a width 0.1. The width of the confidence interval is determined by the margin of error. In fact, it is twice of the margin of error. This suggests that the MOE should be 0.1 over 2, that is 0.05. The sample proportion is not given in this example. We would have to use a conservative estimate of P bar, which is 50%. The solution to this example can be found on our course page. Over here, this table shows that as the sample size increases, the MOE falls. To have a MOE of 5%, as asked in the previous example, we would have to sample at least 385 students. This example is fairly similar to the ones that we have worked on, except the second part. The solutions to this example can be found on our course page.